right. So naming, ionic compounds warm-up review here. Looking over here at writing the names from the formulas. So here, you already were told that these are all ionic, so we're going to just follow the rules. Now, what do we do the first part of the name always? What do we do here? Anybody remember? Just write the regular name of the element. Exactly right. The regular name of the metal, like it's on the periodic table. It's exactly the correct answer. So for Ni, that's going to be nickel. Okay. And now looking here, S2O3. What does that tell me about that particular part of the formula? It's the anion, but where do I need to refer to figure that one out? It's a polyatomic anion. Very good. So I look at my list and go from there. What is S2O3? Thiosulfate. Good. So that's the second part of the name. There's one other thing I should ask myself about is this particular part of the formula. Does it need a Roman numeral? Yes, nickel is a transition metal. It is in the D block and it's not one of our exceptions. Now we have to figure that out. What is the charge on the nickel? What is the charge on the thiosulfate? Because that one you know on your table. This is a -2, right? And there's 3 of them. 3 minus 2s, that adds up to a total of -6. So if there's 2 nickels that have to add up to a +6, remember this needs to add up to 0. That means the nickel is a +3. Very good. So I need a Roman numeral 3 here. Exactly right. So that would be for this particular one, naming it. How about this one? What's Ca? Calcium. So let's write in calcium. Very good. Does calcium get a Roman numeral? No, right? Because calcium is part of group 2, the alkaline earth metals. It always has a +2. So the alkaline earth metals, the alkali metals, zinc, silver, cadmium, all of these ones that only have one oxidation state, they never get Roman numerals. So this one, we don't have to worry about a Roman numeral. And then all we do for bromine is change it to what? Bromide. Very good. We're going to change that to bromide. That one's a nice, easy one. All right, looking here. Mg. What's Mg? Magnesium. Good. Does magnesium ever get a Roman numeral? No, it's also an alkaline earth metal, always +2, right? Good, good. Now, NO2 has 2 elements in it, so this must be also a polyatomic. What's NO2 on our polyatomic list? Nitrite. Very good. So that's that one. It's the ITE one, that one. All right. Now, but could anybody tell me what nitrate would be then? If I know nitrite is NO2, can anybody tell me what nitrate should be? NO3, add an oxygen. Very good. Remember the 8s have one more oxygen than the ites. Good point there. All right, Fe. What's Fe? Iron, very good. Now, is iron need a Roman numeral? Is it a mom? Yes, it is. It's in the D block, it's in the transition metals. It's not one of our exceptions. So if we're looking here, we could always write in the anion here. What's just S by itself? Well, what name would that be? Well, it's sulfur, but sulfur changes to sulfide. Very good. We put sulfide here. Yes, change it to IDE. Very good. Now, what's the charge on the sulfide? Always from the periodic table, because it's in group 16 under oxygen. Good. -2. So there's one of each in here. What does that mean about the iron? What's the charge on the iron? It's got to be +2. So that means I put a Roman numeral 2 here. Very good. So this is kind of the systematic steps you should be using when you're looking at naming and writing formulas. Now, I think this part's harder than this part over here. I think taking the name and writing it is much easier than trying to write the name from the formula. That's my own opinion. Going back over Roman numerals one more time, yes, you want the ones that have more than one oxidation state, and most of them are in the D block. Most of them are in that transition metals. So zinc, silver, cadmium would never get a Roman numeral, even though they're in the D block, because they only have one oxidation state or one charge. And then don't forget tin and lead, which are not located in the transition metal block, do get Roman numerals because they do have +2 and +4 oxidation states. All right, very good reminder on those nuances, because those ones, like I said, exceptions are tough. All right, so cobalt 3. Now, if I'm writing this formula, what does that tell me? What does this 3 tell me about my cobalt? It's a +3 charge. Now for chloride, what's the charge on chloride? -1, good. So how many of each do I need to make this formula work and add up to 0? One cobalt and 3 chlorides. Very good. So this would be COCl3. So think about the ratio of what you need to make it add up to 0. All right, what is strontium's charge? Good, it's in the alkaline earth metals. I guess I should write it formal charge way. It is an alkaline earth metal, so it's always +2. Good, it's in group 2. Now, on our polyatomic list, what is acetate? It's kind of annoying, it's long. C2H3O2. What's the charge on acetate? -1, good. Now, how many of each do I need to make this work? One strontium, 2 acetate. So SR, now what do I need around my acetate? What do I need around the parentheses? Good. So we would put the parentheses around the entire thing and then write the formula. All right, looking here. Aluminum sulfate. What is the charge on the aluminum? +3, good. It's in group 13 or 3A, so it's going to be +3. What is sulfate? Off of our polyatomic ion list. That's SO4 -2. Good. SO4 -2 is sulfate. Now, how many of each do I need to make this formula work? We have a 3 to 2 here. Yeah, 2 aluminums, good. And parentheses SO4, and then the 3 outside. Remember, this is plus 6 now, minus 6 adds up to 0. All right, ammonium, the only polyatomic cation on your list. What is ammonium? NH4, what's the charge on ammonia? It's plus 1, good. What's iodide? What's the charge on the I? So this would be a minus 1. Very good. So one of each here, that's here, NH4I. Okay, so just a quick practice on naming ionic. We did Roman numerals, we did polyatomics, we did regular binary naming. So it's all rolled into these 4 examples. Now we're moving on to covalent. You need to review the answers, of course, obviously they're right there. Okay, so looking here, naming and writing formulas for covalent or molecular compounds. So sometimes you might see the word molecular, and it's referring to things that are covalent compounds that have a sharing of electrons. Different way of doing the bonding, and we're going to go over the properties and the structure of the bonding next week, but sharing of electrons, different types of elements involves, and a different naming system that goes with it. So the covalent molecular compounds generally form from the combination of 2 or more nonmetals. That's one of the key things is you're looking for nonmetal. Sometimes it's nonmetal metalloid, but you should not see any metals in a molecular compound. Now, covalent bonds are from the sharing of electrons. We'll talk about and show the structure of the bonds next week. Covalent bonds are weaker than ionic bonds in terms of strength. They have lower melting points. That's one of the properties. Like I said, we'll talk about next week in detail. And then they use a prefix system. Prefix system when they're naming and their formulas. Okay. The prefixes are very similar to the ones that you use in math if you're talking about a pentagon or, octagon, stuff like that. Some of them are a little bit different, but the first prefix, mono, di, tri, tetra. I'm sure you've heard of Tetris. Well, the game Tetris is based off of a series of 4 blocks. Well, that's where the 4 blocks come from. And Tetris part, tetra means 4. Penta, like the pentagon. Hexa, hepta. Now, I like to remember hexa versus hepta because 6 has an X in it, so hexa goes with 6. Hepta's the other one, that's 7. Octa, obviously, octopus or, any of those things with 8 there. Nana, and then deca, like decade, okay? 10 years, decade, where these prefixes come from. These are the prefixes you're going to use in the naming system. Rules. Mono is never used on the first nonmetal in the formula. So if it's only 1 in the first of the formula, you just name the element. The second nonmetal in the formula will always have a prefix. All formula names end in IDE like the anion name. So the second part, the ending part, is going to end in IDE. No double vowels for oxide molecules. So what do we mean by that? No OO or AO combinations in the name. Let's look at that. An example would be monoxide and not monooxide. So there's no OO here. We just go monoxide. We take out one of the O's. Another example of that would be tetroxide. We don't say tetraoxide, we say tetroxide. So it looks more like this over here. So this is a no, this is a no. No double O, no AO. Exceptions, NH3. we don't call that nitrogen trihydride. Even though that's the technical IUPAC name for it, nobody calls it that. Everybody calls it ammonia. And this is like the chemical that's in Windex and stuff. It's a cleaning agent. Ammonia is NH3. Just like ammonium was NH4 plus, they're kind of derivatives of each other. Ammonia, when you see NH3, don't name it nitrogen trihydride, name it ammonia. The other one is methane, CH4. That's the organic name, and organic compounds have carbon in them. Nobody calls CH4 carbon tetrahydride. They call it methane. And we'll do a little bit of organic later, but you know, that's like the stuff that comes out of your stove, the gas in your stove, and you know, any kind of natural gas would have lots of methane in it, and you just kind of have to memorize those. So that's just the way it is. All right, so let's look at some examples. We have P2O5. So the 2 here means 2-phosphorus. We use the prefix di, and we just say diphosphorus. The 5 here, of course, means there's 5 oxygens, and that's pentoxide. Remember to take off the OO. So it's just one O in between, pentoxide. Second example, you all know this one anyways, it's carbon dioxide. Well, why is it called carbon dioxide? Well, this is an understood one here. Remember, we leave off mono off the first word always. So it's just carbon, and then the 2 here tells us dioxide. The last example here, CO, which is, of course, a 1 here as well. But the second one's also a 1. You leave the mono off the first word, like we always do, but everything on the second one always has a prefix. So you would not leave mono off if it's in the second part of the compound. Carbon monoxide. So CO versus CO2, carbon dioxide, carbon monoxide. Now let's do a few examples together real quick. And basically what I want you to do here is take the formulas over here and write the name. Take the, you know, name, and over here write the formula for practice. So N2, what does that tell me? What prefix should I use here? Di. So this is how I would write it. I would write dinitrogen, just name the element. And then the 4 here, what prefix is that? Tetra. So this is tetroxide. Remember, we dropped the A. All right, so that would be the example for naming N2O4. Over here, how do I write the formula from this? Well, I look at this, I say di means 2, and this is hydrogen, so I do H with the subscript 2, and then it says monoxide, that's going to be O. So that's the IUPAC name for water, but does anybody call it dihydrogen monoxide? No, everybody calls it water. All right, let's do a couple more here, a couple more examples, like SO2. How would I start this one, SO2? No prefix, very good. So I would just write sulfur. And then 2 right here means dioxide. Very good. Let's look over here. Sulfur hexochloride. So what does that mean? The no prefix on here means just S, no number, it's mono, yeah. And then hexa means 6, so this would be Cl with the 6. All right. Let's see here. Let's do this bottom one. What's that? What's the 3 going to be? Tricarbon, good. And then the 4 here would be tetranitride. Not too bad, right? How about this one? How would I name that one? Thank you. Yay! Somebody paid attention to my exception rule. This is methane. CH4. Yay! Okay. I was trying to trick you, so there you go. Sorry, but yeah, I had to throw that in there. So remember, CH4 is methane, NH3 is ammonia, period. Just throwing that in there for fun. All right. Let's try Hexaboron Monosilicide. That one sounds like a mouthful. That's going to be what? How would I write the formula for that? B6, good. Then what? What's silicide? It's very strange. It's got to be silicon, good. I. Yes, it's actually B6. Br would be bromine. So B6Si. Very good. So this naming system is not particularly challenging. Just, learn your prefixes. You can do more of the practice here. And like I said, you'll see a few problems in your choice board assignment that have these examples in there. Are there any other ones you want me to do before we look at acids and base naming? All right, sounds good. We're going to go ahead and stop there and then look at acids and base naming.